Hey guys, in this video we'll be covering the Smart Cell tool. It's going to be located here, and I'm going to go ahead and open this toolbox. So what's going to happen is I'm going to make a cell for this ramp, and then what I can do is apply that cell to other ramps with similar structures. Alright, so first I'm going to set up a guideline and start extracting the curbs from or using my breakline generator. And what I'm going to try and do is have my template points. There's going to be 4 of them, so edge pavement, flow, top, and back of curb. And I'm going to have it on both sides of this feature. And then from here I'm just going to manually draw, and then once that's done we can convert this into a template. Okay. And I'm just going to get a small portion here. Alright, accept that. I'm just gonna rip through this here, because you can see this tool and all the details later on. And I basically just took a cross section down the face of the ramp here to figure out where it's starting to break. That way I can set my position. Okay. Alright. So I have, my templates on either side, and we have for each blue, there's another blue, and they're pretty much symmetrical. So now I'm going to go ahead and start drawing my feature here. And I'm holding Control. I'm clicking towards the top of the ramp. Oops. Okay, and depending on how many active points that I want in here, we can throw in as many as we want. So for now, I have a handle here, so 4 handles to represent the back part. Now I'm going to add information in here that I can use. So I can have either drape points or drag points. These back points are going to be the drag points. And then these points in here are going to be draping. So they'll just drape down to the data. So let me go ahead and set this up now. And I know I'll have a point right here. You can see the crease. Okay, so I have the general shape of my template. And if I want to, I can even add this feature here just to connect those points. And I can even add as well here. Just keep in mind, if we want to add a drag point or a drape point, there has to be a handle for the tool to associate with. So there's the general shape that I'm going with. And now we're going to take this and apply it to a similar situation over here. Well, first, we want to create the smart points. So in this case, we're going to use convert since we already have our attachment points here. And essentially, these attachment points will only be used for fitting the cell. And then the drape and the drag point will be slave to this orientation. So the attachment points are the important ones when it comes to fitting, because we're going to have this similar profile on the other side as well. So actually, let me quickly just get this. I'm going to go ahead and disconnect these lines. So I toggle that on and off. That was actually fairly close. Okay, and that's pretty much enough for that. So we can see that when we end up with a situation where we have a left and a right condition here, and the profile is the same, these are our attachment points that are going to correspond with these attachment points. So these 4 and these 4. Let's go ahead and convert these points now. And when we click on the point, we're going to get a little circle around it. And it's basically based on color. So what this is doing is converting those template points, edge of payment, into a teal color. We can create our own color if we want to, just simply by creating. So this is going to create an orange point if I wanted to make that an attachment point. But we do not have this attachment point in the other situation, but you can add as much as you want. And if you didn't have these curve points, that's where you would select the colors here. And you'd have to create them instead of converting. So now we have all of our points for the attachments. Let's go ahead and move on to the drape points. So I'm going to locate all the points that I need to drape. So I want this to be a drape point, and I'm going to want to have this a drape point. So now when this template's fit, or when it's fitted, it will automatically drape these points to the data that it encounters. Now for the back, I'm going to have these as drag points, because the drag points aren't as uniform throughout the project, so we can manipulate these as we go. Okay, so in the future we'll see that as I modify these drag points, everything else that's connected to this point will move with it. So we don't have to worry about adjusting these lines as we go. Everything will move together. Same with the drape points and the attachment points. Everything will be pulled to the corresponding locations. Now we need to save this template, essentially. And to do that, what we're going to want to have is a cell library dedicated to these ramps here. So let me go ahead and find mine. Okay, so I just attached my file, and I called it a ramp cell. And I already have a couple of ramp situations in here. But I want to go and show how to add this ramp to the list so we can use it. Okay, so we do not want to include these points in our selection process. So we're going to go ahead and delete those. make sure not to delete the actual template points. We just don't want them in our selection process. So either we can delete them or deselect them. So actually, instead of deleting these, I'm going to go ahead and do the alternate method here. To create a cell, we're going to have to place a cell origin. I'm just going to have that placed in the center. You can have it placed on a corner, doesn't matter. I'm going to select all of the elements that I want involved with this cell. And again, I'm going to have to deselect these template points. So that will be back a curb, edge of payment, flow line, and top. And we only want the template points, our ramp information, our drag and drape points. Pretty much only what we want to include in the cell. So now once that's selected, we'll go ahead and right click, new, lamp 7, create that. So now it's within our cell library, it's saved for future use. Let's go ahead and apply this. Okay. Alright, so in order to apply this is we're going to open up our list of smart cells, and depending on which one we choose and how many points we have selected, it's going to fit that cell to it. So if I just click once, it's going to give us a preview of how it's going to fit. And we can see that in this orientation. Some templates might not fit exactly right, but if you right click, it'll filter through the different options or the different orientations. That's if it's like pointing upwards. But this fit is looking good, so we're going to go ahead and double click it. And if you noticed, our corners here have been pulled to the attachment points of the existing curb work, and then these points have been draped to the data. And it may have been a subtle difference, but if I we might not be able to see that here, but if you noticed, our drape points are gone. So the only thing that is left behind are the drag points. And let's go ahead and drag these into our proper location. So these look a little bit short from the actual sidewalk. So I'm going to activate my drag point. And as I move this, this is going to automatically drape to the data. And it's going to have a sample size with this radius value. So I'm going to grab my data point and I'm going to click in the location of that corner here. And if I already had my sidewalk, that would probably be good too. And that's the ramp. Also, if I wanted to include my line here for the edge of pavement, I could have just included another polyline in here, maybe even with a few drape points. You know, I honestly don't even, you don't have to include the edge of pavement lines if you have these 3 points. You should be good enough. Let's go ahead and see if we can select only a few points here. So we're going to select these two and these two. Just make sure if you have one point selected, the other side has to be selected. Alright, so there's option 1, and you'll notice that it will only adjust towards the active points, so it's not going to adjust to the back curb, but it's still enough to help fit this template. Okay, and we could just simply drag that on if we need to. And some other features we can apply this to are possible drain inlets, anything that has a repeating shape that will have a unique left and right boundary situation where you can do a least squared fitting of this template. Alright guys, good luck.